Our planet is facing unprecedented challenges caused by our over-reliance on fossil-based resources. A paradigm shift towards a circular, bio-based era is imperative. The Academy of Finland's flagship program, FinnCERES, hosted by VTT and Aalto University, enables deep-rooted science to address some of these major challenges. In a mission to redefine the bioeconomy, FinnCERES is developing novel, sustainable uses of our precious natural resources.
Plants are as material banks. They are an endless inspiration for materials engineering when looking at the building blocks, looking at the structures, plant cell wall structure and plant cell wall function. And this I would call like bio-inspired materials engineering. The idea is not only to replace the fossil resources, but use this bio-inspiration to create new material solutions that doesn't even exist yet.
We need to utilize less fossil carbon in our materials, but when utilizing our limited biomass resources, we need to do it in a sustainable way. And this means that we need to use all relevant feedstocks and also utilize all their valuable fractions. So not only the cellulose, but also lignin, hemicelluloses and extractives.
The flagship program has 5 focus areas: future biorefineries, clean air and water, lignocellulosics beyond plastics, electronics, optics and energy applications, and fundamental research. The fundamental research aims to unveil the untapped potential embedded in the inherent properties of woody biomass. Lignocellulose offers vast unutilized opportunities in material solutions. To complement traditional kraft pulping, novel solvents, new bioprocesses, and enzymatic treatments of lignocellulose offer selective routes for extracting valuable fractions that can be applied to brand new areas and end products. While the pulp industry has battled for decades with the high hygroscopicity of pulp, FinnCERES researchers have turned this detrimental feature into an ocean of opportunities, ranging from water and air purification filters to combating microplastics and pharmaceutical residues in wastewater treatment. The lignocellulosic building blocks can be used to replace plastics, but perhaps more importantly, to create entirely new materials that are lighter, recyclable, use less energy to produce, and do not create harmful microplastics in the environment. Groundbreaking discoveries are being made in optoelectronics, medical sensing, bio-based semiconductors, energy harvesting, and energy storage.